let's see what we will be covering. So up till now, what things we have looked at, right? Let me put a full screen for you. So the key points from our last module was we have looked at HA, right? Our main class yesterday in previously in the last week was we set up HA using shared storage and journal quorum manager, right? Two ways we set up high availability. So in production, we will be using high availability, right? All the companies have moved into high availability. We do not anymore use a secondary name node because we will be anyway using a hardware, same kind of resources. So it does not make sense. So it is better that we have the best use of the other server. So we put into high availability. So I've showed you how we can do in two ways. And I also showed you the advantages of yarn. And what was the advantage of having a yarn framework? I can run heterogeneous servers, right? I do not need to have servers with the same amount of configurations now, because now I don't have to manually do the calculations of all the resources which each node will have, right? I do not need to worry about how many mappers and reducer slots I have per node. That is automatically now taken care by the framework, because we are not talking in terms of slots. Now we talk in terms of directly in terms of percentage of the container, right? So that container can be for a map or it can be for reduce, right? So let me help you recall this what we have discussed in our last class. In Hadoop 1, we were saying how many mapper slots, how many reducer slots I can have. Let's say if I say there can be 4 map slots and 2 reduce slots per node, for example. So what happens? Let's say on one of the node, I have 4 mappers running and there are no reducers running on those node, and these 2 slots are empty. I cannot use them for mappers, although they might be empty, because I have explicitly specified them for reducer. But in the new framework yarn, this logic is not there. I do not say, or we do not say, that how many mappers or reducer slots we have. We simply say container memory. Container, right? I showed you the container. When we were running the job, there was a yarn child which was coming. So I'm saying container. Instead of saying map reduce, I'm saying resources per container. Within this container, it can run mapper reducer. It is not a headache of the Hadoop admin anymore. So we don't need to go that granular into the configurations. Okay. So a lot of details are there, right? In the, I have given you an assignment also. I did not see anybody coming back to me on that, right? So I'm not sure how many of you are actually practicing things. So it's very important you guys practice. So in the class, it is not possible for me to show everything. So in the assignment, I have given you some users. I don't remember from the top of my head what assignment I gave you. In that, I gave you few users. For example, let's say Amit is one user, Rohit is one user, and I said each user has been given some capacity of the MapReduce cluster. I said Amit can run 10 mappers, Rohit can run, let's say, 6 mappers. And I have said that Amit is assigned to a queue marketing and Rohit is assigned to a queue finance. So assignment was create job queues for each of the user and make sure they get these resources, and how you control the resources, right? It was, I think, assignment 3 which I sent you through email. Anyways, please do that and reach out to me with any questions. So now let's start our today's class. So as we see, Hadoop had a very humble beginning because it was as more of a lab kind of a project or a development kind of a project, but it grew rapidly and lot of components were added into it, as it went along, right? In terms of, let's say, databases, in terms of query layers, in terms of machine learning, lot of things were added to it, and it grew at a very, very rapid rate. So today we will be looking at some other aspects of Hadoop. Up till now, we have talked about how to set up a cluster, how to run MapReduce, how to do different admin tasks, right? But now we will be looking at some of the ecosystems which go with Hadoop. For example, how you will upload data into Hadoop. Up till now, we have been doing simple Hadoop command, Hadoop fs put or get or copy from local, those kind of things. But how you will ingest data, large data, for example, from a database. You might have a MySQL or an Oracle database. How will you upload that data to Hadoop? Or how you will upload data from Twitter? Or how you will connect to Apache logs? You want to collect logs from Apache servers, right? Front end web servers, and upload into Hadoop. How you will do that? So today we will be looking at those aspects. So today we will be talking about pig scripting, Flume, Hive, Hbase, and Scoop as well, right? So these are the main four things we will look today, right? There are a lot of two other tools as well, but we will keep our discussion to these tools because these are the most popular tools in the Hadoop side, and they have been there for a very, very long time. So before starting with those tools, let's look at what are the other use cases of Hadoop other than simply running it for MapReduce. Can I do something else with Hadoop? So first of all, Hadoop is not just for analytics. So when I say this, it does not mean that I have to run MapReduce. But end of the day, it comes to the cost of ownership. So if I'm setting up a 100 node cluster, end of the day, the question comes, what is the use of that cluster? What I'm using that for? So there are use cases where people are using Hadoop for warehousing as well. So what they do, they are storing the historical data into Hadoop, and it is saving them on cost. Instead of having expensive storage devices, they are storing it on Hadoop. So I'm not saying it is replacing storage or it is replacing warehouse, right? It will never do that. But thing is, it is reducing the burden or the cost which goes on SAN. Instead of putting, let's say, 1 petabyte of data, we might be just putting 500 terabyte on a SAN. I need a smaller SAN now. So what is the advantage of doing this is I can keep more data live. Live means in our traditional systems or warehousing, what happens? Let's say I have set up an Oracle database. How much big that database can grow? 1 terabyte, 10 terabyte, or let's say 1 petabyte, right? That's an exceptional case. I'm just talking about database. After that, what you will do is you will start archiving that data and moving it to some secondary storage. It may be a tape drive, any other storage. Means you will be compressing it, archiving it, and storing into a warehouse. And whenever the need be, you will pull it back, load it, and run a query on it. So what is the disadvantage of that? Especially in this present age, when you have so much competition and you need to better position your products and better target your audience, how you can do that? More data you have, better you can target your users, better you can understand them, because you have more data to play around with, and you can do much more accurate predictions. It could be a predictive model, it could be analytics model, so you can better understand. So there's a very interesting use case by a company called Sears, Sears. Sears, it is a retail chain in US. So they were initially using Teradata and Oracle combination. So what was the challenge with them? They approximately had 2 terabytes of data, but out of which they were keeping hardly few gigabytes of data live into Oracle, rest they were moving into storage. So what was happening? They were able to target the customers in a very shorter span of time, means over a trends over the last 2 months or 3 months. Then they moved into Hadoop. They uploaded the entire 2 terabytes into Hadoop cluster. So now they have the historical data from the very beginning. They understand what is the customer buying behavior, how the market is changing, what is the geography or geolocation for customers, and they can better market their products. As I said, Hadoop is not a replacement for RDBMS or warehouse, but it reduces the cost. It may replace the data platform, but not necessarily the relational or processing or the modeling approach. What does it mean? The platform. When we say a data warehouse, what it involves? It might involve a storage layer. I may have a combination of multiple servers, storage layers, and on top of that, I build a modeling layer, OLTP, OLAP, right? Different hierarchies. So what Hadoop will replace? It will not replace your transaction processing. In banks, you will always have Oracle, MySQL, those kind of transactional databases, because Hadoop does not support transactional databases. I cannot have a banking domain entirely running out of Hadoop. So very important to understand, as many people are marketing outside, Hadoop will replace the RDBMS. That is not true. It will never replace it. What it might replace? It might replace the data platform. But still on top of that, you will have your old tools. What is Hadoop used for? Right? Let's say in a company, you have Oracle MySQL where Hadoop will be used. You will be uploading a lot of data. What Hadoop will do, it might filter it. It might index the data for easier retrieval and then upload it into a RDBMS database. For example, let's say I'm getting 10 terabytes of data, which is flowing into my system. Or it could be any kind of data. It could be a clickstream data or users visiting particular website. So all those data is collected. So at the very first instance, I cannot just drop the data because I do not know which data is important for me. So all the data I have to flow into a system. So where I will flow all that data, I will flow into Hadoop. On Hadoop, I will do some processing. It could be some filtering, some comparisons, and I will discard garbage. So out of 10 terabyte of data, I might be left with only, let's say, 2 gigabytes of data. So which is a clean data. So that clean data I might upload into RDBMS, Oracle, MySQL. So Hadoop will be at the front end where it might be doing cleaning for you and number of use cases. So there is a project called Apache Tejo, which is specifically targeted into using Hadoop into warehousing. It is under Apache. So you can go and look into this project. You go to apache.org. This is a project called Tejo, which is used for warehousing. So as I said, Hadoop is not an ETL tool. It is a platform that supports running ETL processes. So all the data vendors who are into these ETL tools, it may be Informatica, any tool, Tableau, they are acting as integrators for Hadoop. They leverage the Hadoop with their tools. But Hadoop is not replacing any of those things. Very important to understand. So up till now, mainly we looked at Hadoop, storage, and MapReduce layer. But there are a lot of other things which Hadoop talks about. If we go into data science space, there will be some machine learning algorithms. For example, Mahout is one platform. I may use different kind of databases. For example, Giraffe, NeoDB, right? All those kind of things. But today we will be talking about how you will be uploading data into Hadoop, or how you will be exporting data out of Hadoop to various systems. So what all systems could be? For example, let's say I might be running a Hadoop cluster. If I want to load some data into Hadoop, so today how we are doing it? Up till now, we have been using Hadoop fs put command. I'm manually copying it. So at the max, what I can do, I can write a cron job, which might do a copy of some files periodically onto Hadoop cluster. But let's take a use case. I have an Apache server which is writing logs in, let's say, /var log http folder. It's writing some log, let's say access logs. So I want the moment a file is written there or a change in timestamp happens, that is uploaded into Hadoop. How will I do that? So for that, there's a tool called Flume, right? Flume is a contribution by Twitter. I can connect Flume to any of the data sources. It could be Apache web server, it could be a Twitter feed as well, right? You go to Twitter site, create your Twitter API account. It's called Twitter app account. It will give you a username password. You enter that into your Twitter API and you can fetch all the tweets. There's a limit in the free account how many you can fetch, but still you can play around. So today we'll be looking at firstly two tools. One is Flume, other is Scoop. What is the difference between these two? Flume is used for any unstructured or semi-structured data. Unstructured or semi-structured data. What are those? Text files, emails, documents. For example, your logs. Logs are unstructured, or it might be semi-structured because log has some format. Let's say Apache logs. So I will be showing you some use cases how you will upload that into Hadoop. Second will be Scoop. Scoop will be used for structured data. Let's say Oracle MySQL. You have some table, some data in MySQL. You want to upload that into Hadoop or export back into MySQL. So for that we will use Scoop. So we have two tools: Flume for semi-structured or unstructured data, Scoop for structured data. Right? So this is for ingestion point of view. We can do a lot of other things. For example, when the data is uploaded into Hadoop, I can either write a MapReduce job, which is in Java, to do some work on it. But being a Hadoop admin, I might not be comfortable with Java. Or let's say if simply you want to write a word count example, it will need hardly approximately around 60-70 lines of Java code to do a simple word count, which I could do in much shorter time. For example, by using pig, I can do that in hardly 4 lines. So what is pig? So I will be talking about that also. So data warehousing, it has multiple components. Many companies, Twitter, Facebook, all these, you might have unstructured, semi-structured data, which goes into Hadoop. Then you run some analytics on that top of that, for example, R, SAS, right? IBM BI tools, any of the tools, then you give your final output. It may be reports, analytics, or predictive analytics. You may give anything. So for example, Jasper BI is an open source tool which is used for report generation and databases and a dashboard, sorry, not databases, dashboards. Let's look at first tool. So the first tool which we'll be looking at is called Pig, P-I-G. So this tool was developed at Yahoo. So what was the main aim behind developing Pig? So Hadoop is written into Java. So what I need to do is I should be able to write a code in Java if I want to do any kind of processing. For example, the all the word count examples which I have been showing you till now, it's a jar file. Jar file is a Java archive file. Right? Means you have written a code in Java, you created an archive, and it is running on any of the platforms. I need to know Java. But let's say even if I know Java, the timeline to write your jobs will be quite long. It might take 2 days, 4 days, 10 days. So how I can quickly write things, especially in the Hadoop admin domain or the system admin domain. I might need to do some ad hoc request. Let's say there's some data on Hadoop cluster. I want to quickly find out some string in all the data in all the directories. I cannot write a Java code. It might take me 10 hours or 20 hours. So I can quickly write a script. So script is similar to any bash or Python or a Perl script. So Pig was developed with that intent, that the system admins who might not be very well versed with Java, can they leverage the Hadoop platform and do not bother about how MapReduce runs. So what Pig does, Pig is a data flow language which harnesses the power of scripting to chain multiple steps to give a meaningful output. So similar to bash scripting. What is a bash script? It is a sequence of commands we give, right, on which happen on certain conditions. Similarly, Pig is also a data flow language. It's a scripting language for the distributed platform which executes a sequence of steps on certain conditions, right? So this is what it does. So what are the main features of Pig? It lets users to specify the sequence of steps needed for data processing. Similar to a script, you can write your own steps. It is a high level language and it runs MapReduce at the backend. For example, when I write a Pig script and hit enter, fire a Pig script, at the backend it does a translation into MapReduce code. So Pig has a interpreter which will read the Pig code which I write in plain English. It will compile it and it will interpret that into MapReduce code. It will convert into MapReduce code. I can do joins, filter, grouping, easy to write and quick to implement. So what is the advantage? It opens the MapReduce framework for more users. You don't need to be a developer. You don't need to be a Java guy. So it insulates against Hadoop versions. So Pig does not matter whether you are using Hadoop 1, Hadoop 2, Hadoop 2.4, does not matter. Pig runs on every Hadoop version. So it isolates things from you. So obviously there is some disadvantage of Pig as well. Pig cannot run as fast as Java because I said it does lot of intermediate phases. I write Pig, it is interpreted, it is compiled, then translated into MapReduce code rather than running directly a MapReduce code as it happens in the case of Java. So obviously the execution time of Pig will be little bit higher. But it is fine if we consider the total overall development cycle. Let's say I want to write a program. In Java, it will take 10 hours. It might run in 5 minutes. In Pig, I will write the entire program in 5 minutes. It might take half an hour to run. So the total time which I will be gaining from right from the beginning will be huge in the case of Pig. So Pig will be used for a lot of things. For example, let's say all of a sudden your manager moves to you and say, give me the top sites visited by a user in a month. Or let's say what is the most tweeted keyword on a Twitter. So in Java, I will be writing a Java program if I have a project timeline. Let's say you are working on some project, you have that software cycle, and you know that in the next 2 months or 3 months, we have to develop this project. You have the timeline. So in that case, I will be going with Java, no doubt, right? Because execution is fast, it is much more robust, very good way to write your code. But for ad hoc things, I will always go for Pig kind of thing. Quicker to write, no need to write Java. So what is the Pig architecture? It is a high level language to express your computation and execution over Hadoop. You write a SQL, Pig, it converts into MapReduce. So the language which Pig uses, it's called Pig Latin. Pig Latin is the language. So it is based on Erlang. So Erlang, ERLANG, it is also a programming language, functional programming language by Motorola, which is in the telecom domain. Very old, from the 1970s. So Pig used the same architecture, same programming syntax of Erlang. So when you write a Pig, it uses a language called Pig Latin. It has a logical flow, physical flow, and a MapReduce flow. All right, what are those? I will show you that. So when we write a program in Pig, it has some data types, like similar to any programming language. It might have an integer, it might have a float, it might have a character, right? It might have a string. Similarly, Pig Latin also has some data types. Smallest data type is called data atom. It could be simply a integer, simply a number, simply a character. It could be a tuple. Tuple means it could be a combination of fields, or you can say it is an sorted array. Tuple is a sorted array, right? Multiple, it can have 1 comma 2 comma 3, or it can have multiple names specified within a bracket, rounded bracket. It could be a data bag. Data bag is a collection of tuples, right? It is a bag inside which you can have multiple tuples. Or it can be a data map. Data map is a key value pair, right? It's similar to a hash map we have in Perl and all. It is a hash map where you will have a key and you will have a value. So I will show you some examples. It will be more clear for you. So let's go back to the system and look at Pig installation, and I will show you for a few examples. Any questions till now? Right? Anyways, we have just touched upon the theory. I will show you on the system what Pig is and how we will be running it. So first thing, Pig is also a project under Apache. You go to Apache, Pig download. It will take me to Pig site, which is apache.org. I will go here. You will download Pig, right? Latest or the stable. Always go for a stable, which is .15. Pig.15. Right? I will take the tarball, not the source. Source you have to compile. So I will take the tarball. So let me expand the screen. I'm sitting on my client1.cluster1.com. So for the time being, I do not need Hadoop cluster. I will tell you when we need Hadoop cluster. So what I have done is I have downloaded Pig from the site in advance. This one I have downloaded the tarball. What I will do, tar-xzvf Pig. I am untarring it. So untar happened. Clear the screen. So it gave me a untar directory, which will be having your directory structure. It will have a bin which will have all your commands. So the beauty about Hadoop products, any of the ecosystem products, will be it will be using the same structure for all the products. Hive, Hbase, Pig, whatever I use, it will have the same structure. Means it will have a bin directory, it will have a contrib directory, it will have a config directory, and it will have some jars. So here you can see I do not need to worry about whether Pig is for Hadoop 1 or Hadoop 2. It will automatically pick the jar for Hadoop, right? So currently I'm not talking about Hadoop. We'll come to that. I will first show you you can run Pig without Hadoop also. So now I will create a symlink because it's just a scripting language. I create a symlink. I open my bash profile. I will make an entry here. Export pig underscore home is equal to slash home slash Hadoop slash pig. Correct? And I will enter that to the path also. $pig underscore home slash bin colon. So I've added to the path as well so that I can execute the path. Now I say which pig, it should able to pick that. It should be able to pick that. So now by default, okay, let me show you env. So most people are Linux guys, so they will not have any problem understanding, but for the sake of the people who are not familiar with Linux, so whenever we execute any command or any process or any daemon runs, how does it know that what input I should take for a particular field or a particular variable and all? So there are environment variables, right? So if I do env, so you will see environment variables which are being exported from bash profile, or it might be coming from top etc profile or something, right? So these are the environment variables. For let's say inside a script, if I call $pig underscore home, so this variable is available in the shell, exported by the shell. So these are shell variables, means not default, I have exported them. You will see all these variables. So there's a variable called Hadoop home also, because this is the same node which we have been using for our previous classes. In this we have run this as a client. If I do Hadoop fs-ls, this was the machine which we are using as client. So you can see it can connect to my Hadoop cluster. So what happens by default, if I run pig, write pig and hit enter, it will look for Hadoop cluster. What does it mean? The default mode for running your pig is MapReduce mode. So pig runs in two modes, right? Pig runs in two modes. It can run in local mode, MapReduce mode. So if I do not explicitly specify that I do not want to use Hadoop, it will always look for Hadoop. So where it will look for Hadoop? Hadoop underscore home environment variable. From there it will come to know where the Hadoop config files are. It will go into that config file, look for core-site and look where name node is. Look under mapper -site and know where job tracker is or respective daemons for Hadoop. But for the time being, I will be running Hadoop in local mode. So I will say -x execution mode local. It has two modes, MapReduce. So if I do not write MapReduce, by default it takes MapReduce. But if I want to run local, I have to run local. But prior to that, let me go to pig directory. So here we have bin config directory. I go to config directory. Here, these are all logging directories, right? If I open this, this talks about how Hadoop writes logs, info, debug, all, right? it has some feature to connect with ganglia and all that, right? But that's altogether a separate topic. I will open a file called vi pig properties. I will open that file. To run pig, I do not need to change any configuration, but still I will show you. This is a very big file. It takes a lot of parameters. For example, I can set up where pig should write logs, for example. I can give a file. I can write any path. Let's say home slash Hadoop slash pig. I'm saying this is the directory where pig will write logs. What is the debug level? Info, warn, all I can give here. UDF is user defined function and all. Lot of details are there. Default type is MapReduce. I can change the default type in the config file. I can say local also, but by default it is MapReduce. Tej is also a platform which is a contribution by Hortonworks, which is an enhancement over MapReduce. Right, a lot of tools are there in Hadoop. I can give the commands in .pigrc file also in my home directory, so that when pig starts, it loads the commands from there. Right? It uses a file called pig bootup. I can give .pig bootup or I can give .pigrc. In my home directory, it will pick things from there. I will show you that, right? Right? And number of things it takes. Caching enabled, not, right? All those things. But thing is, I do not need to modify anything. What I need to do is mkdir. I will create pig directory. Sorry, let's say pig underscore log. I've created a directory called pig underscore log, and let me go and modify that because pig directory is already there. Let's change the name of the logging directory to pig, right? Not mandatory, but I'm just showing I can write logs. And it's always a good practice to give a separate log directory so that it is easy to troubleshoot. Let me see anybody has any questions. So question is, pig scripting would be done by Hadoop admins? Not necessarily, right? Not necessarily. Pig admin, uh, pig scripting will be might be done by any of your business users also, right? Users of Hadoop. But thing is, what is the expected out of Hadoop admin is he should be knowing Hadoop. He should be knowing pig scripting. Similar to a Linux admin. It is expected from a Linux admin that he knows Bash, Perl, or Python. Similarly, a Hadoop admin, it is expected that he knows pig scripting so that he can write ad hoc queries. Okay. So now let's run pig. Pig -x local. I'm explicitly saying local. Do not look for Hadoop cluster. So it gives me a prompt called grunt prompt. It gives me a prompt called grunt prompt. So what is a grunt prompt? It is similar to a MySQL prompt, right? MySQL, when you enter MySQL, it goes to a MySQL prompt. So when you run a pig, it gives you a grunt prompt where you can run your commands. So let me show you. Okay, I have already set up this because this machine was running something. Let me show you there. So here I have actually a file called pigboot in my current directory. So what this file is, here I have given something which is called pig default underscore parallel. Let me remove this. It is not required for running our labs, but what it is doing for the sake of understanding, it is telling me run 10 parallel map reduce jobs. I do not want that. Our job is not that big. So I can remove this. Let me remove big boot. I removed it. So now let me again run Hive. Oh, sorry, and let me again run local. So now it will give me a message saying it did not find this file. Not a problem. So it is saying you did not tell me the environment. So in production, what will happen is when we are running a cluster in production, what I will write in this big boot up file is I might explicitly write set mapper dot job dot tracker. I can write that. I can write my queue explicitly. Let's say I'm a user Aman. I may not be allowed to submit job to any queue. So I can give my queue name in the config file. But here that is not the case. So that's why I was saying you should have gone through the assignment. It will be easy for you to understand this at a production scale. But let's say anyway you have not gone. So let me give an example. Let's do some processing. So pick in this you will see some tutorial being included with this, right? Some data they will give to play around, some scripts they will give, but let's forget about this. So let me give you an example. I've just created some dummy files. So I've created a very simple text file. So let's say I have users, simple text file which is a comma separated file. It can be any delimiter. Log could be a different delimiter. So here let's say I have a user first name, last name, let's say age, city, and let's say a monthly salary, right? Multiple users. I want to do some processing on that, right? Let's say I want to any example you can take. I want to find all the users from a particular city. Let's say group by city. An example similar to MySQL. So how I will do that in pick. I'll say pick hyphen x local. So now pick can run in local mode, map reduce mode, and then also two modes. Two modes means interactive mode, where I will write everything interactively on the shell, grunt shell, or I can write all my commands in a file and give that file to pick. So I will show you both. So first I'm going interactive mode. So I'm saying any variable a, smaller, small case, bigger case does not matter, right? Because these variables, whatever I give, they have to be same. They're case sensitive, but I can start with anything. I have to use the same throughout my script. I cannot call a smaller case a, it will say variable not found. If I'm saying capital A, I can after that I can say load. Load is a keyword which I can write small case, uppercase, does not matter, right? Load. Load what? Load what? I can give the path to my file. What was the path? Let me say examples. I'm file. I'm saying load this file using pig storage. It's a storage class. I'm saying what is the delimiter? It's a comma separated field. I'm saying load this file into variable A using a pig storage. It's a storage class. We have multiple storage class, binary storage class, text storage class, lot of things, right? So pig storage class is the simplest storage class which can read your files, text files. And I'm saying delimiter is comma. So here I can see what is uploaded in my variable. If I say dump small a, it will not understand. See, unable to find the operator small a. I have to give explicitly whatever I have given. See, it dumped things for me. I can upload like this. I can also say as small case, bigger case, does not matter. As first name, let's say char array, character array, last name, character array, then we had age, character array. You can take int also, does not matter. City, character array, comma, sal is equal to, let's say, int. Oh, typo. Uh, right, so I have uploaded it. So what I'm doing here is, let me scroll the screen up. One option was I will uploading the entire file into a variable A. But now I can also say, similar to how you run your SQL queries, right? I'm saying it is delimited by comma and store each of the delimited values into these variables. Right? I can say B is equal to for each A generate. I can generate any element. I can say F name, for example. If I say dump B, it will pick that for me. Right? So it is similar to your programming. So it depends upon you how deep you can go, what combinations you can do, similar to a SQL one. So I was saying, let's say do a all the people who are from a simpler same city, right? Let's give a name for them. I'm saying for each generate a comma city. C, then I'm saying group B by city, dump C. Correct? So here you can see two users were from one city, so they have been grouped together. Multiple n number of things you can do. I can do addition of numbers, int operations, similar to any SQL query. I'm saying dump. Instead of dump, I can also say store in test, some file name. Oh, sorry, not dump, store. Store, what was the variable, last variable we have given? Okay, let me scroll the screen up. Okay, see, I can say store C in test.out. Okay, let me see, I think I forgot the syntax. Into, sorry, not in, it is into. Right, so I can quit. So there will be a file created here which will be given this name test.out. There will be a directory created test.out. Okay, sorry. Let me quickly reload all things. A, B, C, store C into this. This is a file name. Because it has a dot, I put dot here. It's a special character, so I have to give that way. Quit. So it will write test.out. Go here. It will write me the same way how Hadoop writes. Success file and a part file. And I do a cat here. And it will show me the output. Right? Scroll the screen up. Output. So it is again up to you how you write your queries. Now, instead of typing everything manually, what I can do is, instead of going into interactive mode, I can create any file name, let's say vi first ending with pig. So let me just copy the commands which we ran rather than me typing it everything again. Okay, just a second. Let me run that, because it will be easy for me to copy rather than typing again. Right, so what I'm doing is I'm copying this. Let me put into a text pad. Then I'm saying B something. Then I'm saying C, and then in the last I'm dumping it or storing it. So I can take this file, vi first dot pig, any file ending with dot pig. So instead of typing interactively and doing all things manually, so best way is we will write a file dot pig, and I will give this file to it, local and the script name. So it will run the same thing for me. ls-l, you can see same thing being generated for me. Right? So this is local mode, means it is not looking for Hadoop cluster. So obviously when I have larger data, so use case is distributed computing. So my data will be very large. So I have to have this file on Hadoop. So how will I do? I'll say Hadoop fs-put. So let me first show you. Whichever user runs it, that will have its own home directory. That home directory is not there. So what I will do is I will create the home directory. right? Same here, you can see I've created a directory /user and a user directory for Hadoop user. And I will say Hadoop fs hyphen put example, whatever file was first or test dot this one, and I'm saying put that file into this. Let me go to any of the nodes. Job hyphen list. Or I could have given hdfs job hyphen list. No job is running. Let me give you hdfs, which is the latest command. So it is showing me, oh okay, it's mapped. MAPRED. So no job is running. So let me show you what happens here when we run the job. So what I did was I copied the command into Hadoop file. So now when I run this, let me clear this rm-rf test. I'm clearing locally. There's nothing that will happen locally. Hadoop fs-ls/user/Hadoop. Look in this directory. There is only one file, which is the input file, test.txt. So what I will say now, I'll be running the Hadoop job, big job, but I will be now running directly without -x local. So now what it will be doing, it will look for my Hadoop cluster, look for which file, whatever file I have given inside pick dot first dot pick, which is, let me open this. So now I'm saying load test.txt. So it will go into user Hadoop home directory, look for this file, upload it. So I will run pig. So it is running MapReduce. See, it is connecting to looking for name node, then went to reducer and all that. Let me see job. See, a job came. So it is running a MapReduce job at the backend. So execution will be a little bit slower as compared to a MapReduce job because it is doing a lot of intermediate phases before a MapReduce kicks in. Right, so this is what, let it run. So this is what it does. Interactive mode, non-interactive mode, local and MapReduce mode. It will look for Hadoop cluster. So the obviously the advantage of pig is you have to run it on larger data sets, data which is on Hadoop. This is what I explained you. We can upload it. I can also do a join, right? I can upload data from multiple tables, can do a join. I can run a MapReduce example. So if you look at the MapReduce code of that jar file, it's around 70 lines. Entire MapReduce I can write in just 5 lines. Actually in 4 lines, right? The computation is happening in 4 lines. The word count. Let me check whether I have started my MapReduce cluster. Okay, let me go to my cluster 192.168.1.70 colon 50070. Right, so in the newer Hadoop 2 version, you will get a much more neater, clearer, and colorful interface. And 192.168.69 slash. So in Hadoop 1 for job tracker, the port was 50030. In Hadoop 2, it has changed for resource manager to 8088. You can see job is running. It's saying succeeded. Okay, so let's check. It's saying succeeded. How it is succeeded? Let me check. Okay, slash test.out. Okay, and it's writing part. Let me do a cat. You can see it is completed. So the error it is giving is, I think it is giving only for 10.0020. Oh, okay. Okay. So it is looking for local server. Okay, fine. So this is how you will run MapReduce for using pig. So I can show you this also if you want. I can run this for you, but it does not matter. Right? I can run the word count example on the file Hadoop, any file vi word count.txt. This is word count example counting words in a file, and I'm copying this to Hadoop fs-put. I'm copying this file to user/Hadoop, and I write word count dot pig script. I write, and I write word count. This is the word count example, and I say pig word count dot pig. Okay, so let it run. In the meanwhile, let's look what we have other than this. Any questions till now? It's running jobs. Let me go to the MapReduce page as well. Let's see, you can see one more example has come. It is running. Okay. So now let's go to a second tool, which is called Flume. So Flume is a tool which is a contribution by Twitter. So it's a distributed collection and aggregation tool. Collection of what? Any kind of data. It could be text data, binary data, whatever data you give it to it, it will just poll that data. And it is not mandatory that you have to read or write into Hadoop. I can write into some another file. For example, I may read from HDFS log, or I may read from Twitter feed, or I may read from Apache web logs. I can write it to any other file or to Hadoop. So the main thing how the architecture is, the name Flume is derived from a channel. Flume is actually a channel name for the channel which directs water from a source to some another location. So what will happen is you will have a one source, one channel, and one target. Right? It is similar to if you are from physics background, it creates kind of a potential difference. In physics, we need to understand. We need to study was uh, that when there is a potential difference in 2 points, this is a flow of current or any flow of energy. So similarly, if we are creating a source and a target, so we create a sink. So when there is a sink, it will pull data and it will feed to the another target. So this target could be anything. So here my main thing is I can write this source to be Twitter. So this is a keyword, right? It is not that I can write anything. If I want to do a Twitter, I have to write a Twitter keyword, Twitter underscore server. I'm reading from Apache, I will say Apache underscore server. So there's a documentation you have to refer for what source you want to read from. Then I'm saying, for example, always go and monitor this file using tail-f. So whenever something is written to that file, this Flume will read it, put into HDFS. I can directly put to HDFS. I can write to intermediate channels. I can write to another file. So what it has? It has a source, interpreter, and a target. So interpreter is what? Which interprets the data. Interprets the data means it will take a decision what it should do with data, the data which is flowing to it. Should it merge with some another data? For example, I may have multiple streams coming in to an interpreter. Stream 1, stream 2, stream 3. So this interpreter here I can decide on this interpreter that whether it should merge all these files and give an output, or it should merge two and give an output and keep the one separate. So interpreter is doing that. So I have to define an interpreter as well, which will decide what I want to do. So I can say combine the access log, right? Or similar to in any Apache log, we say what to log. Do you want to log the IP? Do you want to log the host name? Similarly, in interpreter, I can also say what you want to log. Rest you can discard. And on the target side, I can specify a target where it should write. It can write to HDFS. It can write to some file also, right? Your wish. So I will show you both. So let's look at Flume setup. Let's take an example of Apache log read. We'll try to read the logs as they are written and see whether how they are written to Hadoop. Right? Let's look at a demo of Flume. In the meanwhile, let me see what is the output written. Hadoop fs-ls/user /Hadoop. Okay, it wrote word count. Under word count, it wrote part file. Right, and let me get this file for you. So we can see it has done a word count for us. So last line had an enter blank line, so it said 0 for that. Okay, now let's go to Flume. Again, Flume is again a tool under Apache license contributed by Twitter. I will go to Apache side. You can search for Flume download. It will take you to Apache side. You can download it. Right, download it. and save it. So 1.6 is the latest one. So before that, let me just create some dummy data. cd slash ware www html vi index.html. Let's create some file. This is Hadoop admin class module 7. I'm just creating some Apache file. Uh, cd ware www html vi index.html. This is Hadoop class module 7, let's say, right? And IP is 99. Let me go to here, right? So I'm entering some text and it is giving me, and my Apache web server is running. So the purpose of doing this is I want to just generate logs. So if I go here where log, right, it will generate logs for me here. Access logs, which will tell me where it access from, right? Say for example source IP of my Mac machine, date, what was the request, I'm using Mozilla, my Macintosh, right, something. So let me see the same thing from client also. I think we can do that. E-links I might have. Okay, I have e-links. I'm saying dump. It's a browser from the command line just to generate logs. I can explicitly say index.html. Same thing, let me just generate from some another node also. I'm not sure here I have e-links. Okay, here also I have e-links. Okay, so same thing. So I'm just increasing the log size. So it's saying IP 70 was of my name node, 99 was of my client itself. So it's saying me explicitly I have accessed index, some logs it generated. Okay, so let's go back as Hadoop user. So I will untar Flume. Same thing, ln-s Flume. I'll give us short name Flume, right? And I will create a symlink for it, because under bin I will have some commands. So I will say vi.bash profile. I'll simply do yyp here. I'll say flume underscore home flume, and same thing I'm writing here, flume underscore home slash bin. Right? So I say flume, so it is able to complete for me. Okay, so this is, I've set up flume here. Now what I have to do, I have to create a source file which will say I have to go to Apache, right? So what I have to do is, let me clear the screen. I have untarred Flume. Now I have to say that there is a file, access file from Apache. I have to read that. I have to tell Hadoop Flume, and I have to tell it where it should read and write. Intermediately, I can also tell what to do on that. I can also do parsing, which is interpreter, right? I can write rules on that. First, I have to pull access, write it to maybe HDFS or somewhere else. So let's create, first of all, this. First is source. I have to create a Flume source. Give any name. Flume source does not matter. Any naming convention you give does not matter, right? This has to be given to the Flume command, right? So all this is in my GitHub. So let me just close down all things which we don't need, because let's make screen clearer. Let me just go to Flume. So what I will say, I will just copy this file there. I will explain you what this file is. So I'm saying any name agent. I'm saying source agent file I'm giving. I can give any extension not required in the case of Linux, but just I'm giving it here. Simple name, file name. So let me show you what I've written here. Source config, I'm saying I'm reading from Apache. What I'm reading, I'm telling the name. I'm simply doing a log here. Correct? I'm doing a log on this. So obviously I'm doing a log on this. So I have to give a permission to this log file to be readable by Hadoop user or whichever user you run Flume by. Right? Then I'm saying what should be the order in which you should keep a track of the logs flowing in. I'm saying time based. How should I interpret the logs? Host based. For example, I may have a Flume agent which is consuming logs for 20 different servers. How it will identify? I'm saying host based headers. Right? Apache access combined. Combining all the logs. What is the size? Channel memory size means how much memory I am giving it to this one. So I can give any port, any amphiviral port means greater than 1024 or 23, right? 0 to 1023. Any port higher than this, because it's not running as root, any port you can give. This is the IP where I'm running. So save it. Vi flume target dot agent. Now I have to create a target agent as well. Means which will, where I will be actually storing the file. Let me show you what I have written here. Right, so don't need to worry about all, you can copy directly from my GitHub. Avro is a serialization concept. What does it mean? This is available in most of the object-oriented programming as well. You put a serializable in front of a class. That class is become serialized. What does it mean? That only when the stream flows over a network, right? It puts into a stream. Puts into stream means one after the another, so as to maintain a sequence. Right? So as to maintain a sequence. And I can also write. This is optional. Rather than writing to Hadoop, I can also write it somewhere else. Just I'm giving an example. I can create a directory where log flume dir, where it will write intermediate files. I can write on non-HDFS as well and HDFS also. Output type HDFS because I'm writing to Hadoop. So now what I have to do before that? I have to quickly go on this host. I'm logged into client only 99. I have to create mkdir, this directory. I have to change the ownership, and I also have to change the ownership for where log httpd. Right? So what I can do is I can say change ownership root Hadoop recursively. Right, so fine. So I'm just giving it a read permission. So it can go and read the files. Okay, now this is done. So now what I will do, now I will launch the source and the collector. Any you can launch, does not matter. Let's say if I launch the collector first, it will wait because source is not sending anything. It will be in waiting state, right? It will be in waiting state. So I'm saying flume agent -c config which file which is a collector name, right? Let me explain you the command. I'm saying flume ng agent -c config -f flume, let's say target. I can say it is a collector because it is the one on the target side. Okay, let me go to other side. I could have run that by using ampersand so that it runs in the background, but I'm just showing you. On the other side, same machine terminal, I will go, I take this flume agent -n. Here I will say it is a source agent, and I'm giving it into the background. So now let's look at Hadoop cluster. Right, so ls-l/ware log flume. Just a second, what was the name I gave? Okay, anyways, so now what I will show is I will run the elinks command again. I'll take this command again. I will run it from somewhere else. And let's see. Okay, let me see. I think there's some issue here. PSAUX pipe grep flume. get flume target. Okay, let me see. I think it is not able to read. Okay, in the meanwhile, we are in the middle of class. Let's take a 2-3 minutes break and we'll continue after that. In the meanwhile, let me see what happened here. Okay, let's take a 2 minutes break and we'll be back. Okay, so I hope everyone is back. So the issue was with the permission. So the log file access underscore log was not readable by Hadoop user. So I changed the permission. So now we can see. Let me just show you the screen. ls-l/ware log flume ng cat. Right? You can see log is being populated here. So same thing goes into Hadoop also. The issue was with the permission. Right? So let me just show you. We will do one more query. Let's say we'll do a query from here. Right? And same thing you will see coming into this file. See, last entry from my Mac. And same thing you will see from here as well. Scroll the screen up. And this goes in there. Directory structure slash flow data. Cat. Right here also it comes. So whatever you stream, it is written into, it can be written into a local file, some location, and also on HDFS. Right? So this is going into HDFS. So this is how Flume will be doing. So Flume will be streaming your data from any of your source into your destination. So provided it has the right permission. So in our case, the issue was it was having wrong permissions and Hadoop user was not able to read the files. Okay. So how you will do for Flume Twitter API? Same things. The class becomes Twitter underscore server. You have to go to Twitter app site, register your app ID, means you can create your app account. They will give you a token. You have to put that token into the config file, go to Twitter, pull your words. Right? So take this as an assignment. If not, you can refer my GitHub. I've given the config file how you can do that. Okay. Now another thing which is very important. Now Flume has, we have used Flume for unstructured and a semi-structured data. What about structured data? Let's say you have some data in MySQL. How you will import that into Hadoop? So Scoop is a bulk transfer tool which allows you to import or export data from structured databases. Means MySQL, Oracle and all. So it has a connector for it. So how you will do that? So when we run Scoop tool, any of your external data stores, I can import, I can export. When I say import, I can import directly into HDFS. What does it mean? I can run a scoop tool. Let's say I'm running a scoop tool. I go to MySQL. I pull data from MySQL using scoop. I can write this directly onto file system, means HDFS. I can write into Hive, which we will see. I can write into Hbase. It's again a database on Hadoop. I can write anywhere. So this is what scoop does. It also runs mappers at the back end. It does not run reducers. Scoop only run map phases. So what are the map phases? Map phase, when you run a scoop command, let's say scoop import some table, it will run a map job, right? It will use map reduce framework, but it will run only map job, no reduce job. And that map job will go fetch data from MySQL and upload into Hadoop, right? So that is the purpose. How it does that? N number of commands. I can do scoop import connection to my database, username, password. I can give the table name and I can give the target directory where it should go and upload it. So if it is not there, it will automatically create the target directory. I can list databases. I can also do a select here. I do not need to import the entire table or a database. I can do a select also. I can do import from where certain condition means. Let's say where student ID is greater than this. So I can do a selective import also. Similarly, selective export also, right? So let me quickly show you how you will do scoop. So for that, let me go back to my system here. And here, MySQL I'm running. So first thing I need to do for running scoop, let me close down all Flume things, benchmarking. First thing you need to do is create any database, right? For test purposes. Let's say we create a database, right? And let me just use the database. Show databases, show tables. No table is there currently. So let's create a table also. So let's say I create a table. Some dummy name. And I'm creating a very small table just for demo purposes, but your table will be very big because we're talking about Hadoop. Because if your table is very small, you do not need Hadoop. Your work will be done from MySQL and Oracle itself. So I say select star from student. Right, so I have something in my MySQL. So my aim is this should come into my Hadoop, either on HDFS or in Hive or in MySQL. So let me just kill Flume because it is running in the background and it will be taking resources. Flume we are done. So let me just kill the Flume process IDs. So now Flume is gone. Right? So it is clearer. So now I've created a table, some dummy table. and I need to import that table into my Hadoop cluster. So first of all, before that, what I have to do is I have to give permissions to that table. Let's say I log in here. I say show grants, for example, and this is all MySQL stuff. Some grants, right? So whenever you access a MySQL, you have to tell which user from which host who can do, right? To keep things simple, let's say we create a user called Scoop, identified by some password. I called it passwd. I'm creating a user Scoop identified by password. This grants for, I can say here, Scoop at, I have to give the entire name, at localhost, right? So I've created a user. Second thing I have to tell is grant access to any DB. DB was test DB. I want to give access to all the tables of my test DB. To whom? Scoop user. That user might connect from any of the data nodes in my cluster, right? Because when you are running your cluster Scoop job, your Scoop MapReduce framework can decide that to go on any node. So I have to give for all my cluster. One option is I give each node name, or I can give percentile sign here, right? I can give wildcard. So it is your choice. I can give only data nodes you have to give. DN2, DN3, or I can give wildcard for my cluster. I can give DN star as well, dot that. All given, flush privileges, quit, right? ls-l. So now what I have to do, I have to install Apache Scoop here. Again, Scoop is a project from Apache. I will go to Apache side, download Scoop. So now there is slight difference in the Scoop than what we had for Pig. So Pig did not matter whether we are running Hadoop 1 or Hadoop 2, but Scoop is specific to Hadoop distribution. So if I'm using Hadoop 1, I have to download a package which is for Hadoop 1. Right? When I say Hadoop 1 means 1.1, 1.2, it could be anything. It is running job tracker model, right? The MapReduce one. But if it's running Yarn, I have to download a separate one. So I will go here. This is the latest release. So it will tell me 1 or 2, which one I want. So I'm running currently Hadoop 2. So I will click this. It will download this for me. So I will say tar-xzvf scoop. I'm untarring it into /home Hadoop. Change ownership recursively Hadoop :Hadoop /home Hadoop. So Hadoop, I go back as Hadoop. ln-s, same thing. Quickly I create a symlink for Scoop. Oh, not ls, ln-s. I create a soft link. I open vi.bash profile, and I will make an entry for Scoop as well. YYP. So we just keep on adding components. Scoop _ home, and I'm saying Scoop and I will add entry here $scoop underscore home slash bin. Save it, run bash profile again, and let's see which scoop can it find or not. It can find. So it is scoop slash bin. You can see scoop commands here. Okay. ls-l scoop change directory, cd config vi scoop hyphen site. So what this tells us, so there are a lot of things which we can do. I can give my own factories. Factories means my own jar. I can write my own UDFs, user defined functions. I can add my plugins, right? Multiple connections I can do, right? But by default, if I do not want anything, my standard scoop, it will run without changing anything. So now what I will do, first of all, I have set up the scoop path, which I have done. We have set up something in MySQL. But now, let's say if I do something import, let me run any command, for example. Let's say I run this scoop import something, or let's say scoop list databases. Let me just show you this. What I'm saying, scoop list databases, I'm saying connect to my database. I think name is client1. So what is saying me? Could not load database driver class. So Scoop is a generic tool. Similar to any programming language, Java and all, you need to have a JDBC connector for any particular database. So in our case, our database is MySQL. So I need to have a JDBC connector for MySQL. It's provided free by Oracle. So I will say, go to Google and I will search for MySQL JDBC driver jar or connector jar. Same thing. I will click here, which I want platform independent. Click here, take the tar file, download it, right? So which I have already done. If I exit from here, in my root directory, you will see I will have a MySQL connector Java. This one. For Oracle, you have to download an Oracle connector. So I will download this one. So tar-x zvf MySQL. I have untarred here itself in my root directory. So what I am concerned about, in this untarred one, there will be a jar, which is MySQL jar. So what I will do, I will copy this jar into home Hadoop scoop lib directory, and if need be, I will quickly do change ownership once again. So now what I have done is, I took that jar which I have downloaded and I've copied that under scoop lib directory. So now I've uploaded that driver. See, it has come here today itself. Now time stamp. So again, I will run that command now. Right. So now I have not given permission from client1 to scoop. right? I've given for dn1, dn2, localhost, everything, but not for that. So let me correct that also. MySQL-u root -p, I connect here and I quickly give it to client one also. I do quit. See, now it is listing me what databases I have. I have test database. So now I can import the entire database. I can import selectively some tables inside a database, or I can write a query as well to query within a database. For example, I can go to multiple levels. I can go table where something condition, import that. I can say, let's say list tables. Let me change the name here itself instead of changing there. I will connect this. I'm saying list me the tables. See, it is listing me student table. I can import the table as well. Let me import the table. Where I'm saying user scoop test DB. So it will run MapReduce job at the backend. So let me go to Hadoop cluster, Hadoop fs-ls/user. So you will see immediately it will create that directory path. Whatever directory path I have given /scoop whatever, it will start creating that for me. Right, I've given user scoop test DB. After some time you will see if that path is not there, it will create it. So obviously the end part of that, right, should not be there, because we saw when we were running MapReduce, it cannot override. So scoop directory I can create pre-advance, but under that it should not exist. Test DB it will create only when it needs it. So I will take this test DB, right? So part, I'll do cat here, right? See, the users came here. So this is import into HDFS. I'm simply copying that, importing that, and writing to HDFS file. I can do multiple sets. So instead of typing the entire command like this, right, instead of writing the entire big command, I can write this command into an options file also, like this. I can write my all this connection string, username, password into a file, text file, and give it -- option file. So it will read from there, and I can give my syntax that way. I can do query. I can fetch, I can define limit how much should be the size of the query to fetch. This is HDFS import. I can import into Hive also, right? I will show you Hive we will set up. I can import directly into Hive. I can import directly into Hbase. So this is what Scoop is doing. Scoop will be used only for structured data. I can import, export both, right? I can, instead of import, I can also do an export back to NoSql. Okay, now let's close this. Let's move to the next topic, Hive. So what is Hive? So it is a data warehouse infrastructure which is built on top of Hadoop to query your data sets. For example, let's say you have, because RDBMS has been there for a very long time, and you will have your DBAs who will be doing SQL queries, writing complex queries everything they will be very much familiar. So how you can leverage their skill set on Hadoop? So it's not that you have to teach them Hadoop. What you can tell them, you can leverage your existing skill. You are a DBA, you have a SQL, you are a SQL guy. You write your queries. You do not need to worry about how Hadoop runs. We will give you a Hive prompt similar to a SQL prompt where you can run select star from EMP, write everything what you know. So that main reason for Hive was to reduce the learning curve for a DBA. You upload your data into Hadoop, hide all the complexities of Hadoop, how name node, data node, what is job tracker, how they work. Just give him a prompt where he runs his own queries, whatever his familiar word is of SQL queries. So that's the main thing of Hive. Although Hive does not support all the features of RDBMS, for example, running complex composite joins, it does not support that. There is also a difference in how Hive will run. For example, in the case of a join, so I will show you that, but let me uh, give you a demo of setting up and all. So Hive uses a query language called HiveQL, similar to SQL, SQL we call it, right? SQL, which is structured query language. Hive has a Hive query language, similar to SQL. The motivation is to bridge the gap between traditional query writers and the NoSQL ones. It does same thing. It does indexing. It has multiple storage types, text, RC files, right? ORC files. These are the file formats of Hive. Right? It can run on MapReduce, Tej, Spark. But important thing to take care is similar to how Hadoop was. Hadoop was running in standalone mode, pseudo distributed mode, fully distributed mode. Hive can also run in various modes. It can run in an embedded mode, means I just untar Hive, start using it. It will be in embedded mode. Embedded mode means single JVM instance. It will run. Sorry about that. It will create a single JVM. So what does it mean? Only one user can connect to a Hive at a time. Hive prompt, right? Similar to a MySQL prompt, you will get a Hive prompt, but only one user will be able to connect it because it is running in embedded mode, which is its default behavior. I can run it in local Metastore mode or remote Metastore mode. Means I can connect to external databases, MySQL on a same box, remote boxes. So let me show you how they work. Queries will be same. I will create a table, I will load data, I can alter tables, I can drop tables, I can query tables. Right? First, let's look at how we will set up Hive. Right? How we will set up Hive. Same, Hive is again a project under Apache. I will download Hive from apache.org. Hive download. Go to downloads, download a release now. Always go for a stable release. Right? You will find it much more comfortable to work. Right? 1.2.1 or 1.1, whatever you want. Always go for a stable release. Do not go for the latest release. I have Apache Hadoop download, Hive downloaded with me. So let's do tar -x zvf. I'm untarring it. Same thing, create a symlink to ease out the name. And I've given a short name called Hive So I will create vi.bash profile. Same thing. I will go here. I will copy. I paste it here. I will remove this and I will give hive underscore home to hive. And I will enter one more variable here. Hive underscore home slash bin colon. Okay. In the meanwhile, one thing I remember, guys, tomorrow's session, would it be possible to have this session early morning or in the afternoon? Early morning means from, let's say, I'm fine with whatever early time you want. It may be 6 a.m., 7 a.m., 8 a.m., right? 9 a.m. Anytime till afternoon, because in the evening I have uh, something coming up, so I won't be able to take the class tomorrow evening. Or we have to go any day in the next week then, right? So you let me know. In the meanwhile, I will set up Hive, right? So it will be great if it will be possible to take the class tomorrow anytime till afternoon from morning hours, or we can take the class next week. So if you want time to do it, it's fine, right? You can revise all this in the meanwhile, and I can take one class which is remaining maybe next weekend or any time in the week between, right? Early mornings or evenings, right? It will not be possible in the daytime, either early morning or same time in late 8 to 11. I will drop an email to everyone to let you know. So we will go as you say. Okay, I see two people saying next week. Okay. Anyways, so I will see. I will just send out an email to everyone, and I will see what people respond, and I will update you quickly. So anyway, it will not be tomorrow early morning because people will not get time to see the email. It will be either tomorrow afternoon or it will be next week, right? So I will let you know. Okay. So anyway, so we are setting up Hive now. So let me say which Hive. Oh, okay, I have not re-import my profile. Okay, which Hive? cd Hive, same directory structure, ls-l. It has a bin, it has a config, and it has example. cd config. If I go here, it will show me it has some files. So I can copy hive default.xml.template to hive.default.xml, right? I will rename it. So now I will get one hive default file, right? Here in this file, there's a parameter called warehouse. Right? Which file? Hive hyphen default.xml. By default, it will not be there. There will be a template file. I will copy that template file to a default file, hive hyphen default file. I will open that. So there's a warehouse string in that. So this warehouse string will tell me where on Hadoop will be my warehouse for my Hive. Means whatever I put into Hive, whatever I query on Hadoop, where will be the location? I'm saying this will be the location by default. I can change it to whatever I want on Hadoop, right? It should be on Hadoop, not local. So this user Hive warehouse is on Hadoop. If this path is not there, it will automatically create it, whatever I give here, or I can create it manually, right? I can do something like, let me show you here. I do not have anything. Oh, I've not given the last part. User. I do not have Hive here. I can create slash Hive slash warehouse if I want in advance. mkdir hyphen p. Right. All these things are given even again in my GitHub. Right, again they are given in my GitHub. So what I have to do here is, let me show you. I've created a directory. If I'm pre-creating that directory, this step was not required. mkdir-p, this step was not required because it was already in Hive hyphen default file. The moment I run Hive, it will automatically create me for write permissions with the right permission. But if I'm creating that in advance, what I have to make sure is this is writable by group. Mode, I say group plus write. I'm making sure this is writable by group. So I'm adding permission here, second field. Otherwise, best is you do not create this. Hive will automatically take care of it. Okay. Another file. vi hive env.sh template. So this is the template file where you can specify what is the memory you want to give, where the Hive config directory will be. All this you can control from here, right? If required, your wish, not mandatory. So after this, what I will do, I can set up things. What is the difference between Hive and other thing is, let me show you here. If I do Hive, hit enter. So the very first time we launch Hive, it will take some time. Which version of Hive I have used? Hive 1.2.0 I've used. Just give me a second. I'm using wrong version of Hive. Unless Hive cd/data cloud cp. One dot one. Root at 192.168.1.99. Okay. I am removing the Hive here. I did not notice I have downloaded an unstable release. jar hyphen xzbf hyphen c home Hadoop. Okay, let me remove this one from here. Okay, Hive is here. Okay. Mhm. cd hive config. env.sh. Let me give it one more try. Otherwise, I have to look into this, why Hive is not running. Just give me a second. Let me do a quick search on Google. Oh, okay, I think we need to import a variable for this exception. Yeah, this I have to import into this. Yeah, I remember this. pi.bash profile. Okay, what this variable does actually, so the class path, there are two class paths which play a role in Hadoop. One is Hadoop class path, other is the ecosystem class path. For example, there will be config files and jar files which will be coming from Hadoop. Others will be coming from each of the ecosystem. For example, Hive, Pig, and all. So when I set this true, I'm overriding saying it should come from the ecosystem. Right? So I think the previously also the problem was not with the on Hive 1.2. It was mainly with the variable was not set up. Okay, so now it has come. So many things like it keeps on Hadoop. The best thing, or you can call it as the problem with Hadoop, is the ecosystem is changing so quickly. There will be a lot of things which will be coming up every day, how things are invoked. So you have to refer maybe some blogs or do a Google search, the best thing. So I'm just overriding the class path where it should look for. Okay, so I'm on Hive prompt. So I can do here same thing, show databases. It's a data warehousing tool for me for Hadoop Hive. It is looking for databases. Show tables. I can create all those things. I can say create table pokes. I can insert into pokes. I can load data into it. Right. So let me show you the path. For example, let me go to this client ls-l. I'm sitting in cd hive pwd. I'm sitting on a client only. I've opened two terminals to the client ls-l. So here you will see examples directory. Some examples have been given with that files, right? So there's some file, a lot of examples have been given with some queries to test, right? All this example files. So what I'm doing here, I'm loading that into pokes, a file who has two fields, int and a string. That is what I'm doing. So path will be examples or where I'm executing, not sure. Okay, let me see. Yeah, so it is uploaded. I say select star from pokes. So it is fetching me the records. Similar to SQL. But the important thing to look for is when I'm running this command, I'm saying load data local. It means it will look for this file path on non-HDFS location. If I do not give local string, it will look into HDFS path. So I have to copy this file on HDFS some location. If I give local, it will look into non-HDFS path. And what happens where this pokes and all that gets created? Let me go to Hadoop fs-ls /user/hive. In this we have created warehouse directory. Inside warehouse directory, whatever table or a database I create, it will create a folder for it. Let me explain you. In Hive, if I create a database, it will create a folder by the name of database.db. Let's say my database is test, it will create test.db folder. For each table, it will create a directory, right? It is creating a directory anyway for table also and database also, but database will have a .db extension. So here we have not created database, we have just created directly pokes table. So it's showing me it has created pokes table. Inside that, it will simply put the file. Which file? The file we have uploaded. If I go and do a cat here, right, it has uploaded the file from the location I set. Same file is here. I can cat this file, right? So now the question comes, in pokes table, I said foo int bar. Then how it is? The file is coming like this, int and a string. And when I'm doing a simple cat also, it is coming like this, right? But why when I'm doing a query, then it is coming as a separation? So what is happening actually? From a file system perspective, what it is simply doing, It is simply going and writing that file there into a particular location in HDFS. I can myself go and copy this file there. But what is happening when I'm doing it from Hive? When I'm saying create table and all, it is creating a metadata. And when I'm loading it, it is mapping the metadata or the schema to the data. And where that delimiter is coming, by default, delimiter is control A. By default, the delimiter is control A. So whatever data I put into it, it will be delimited by control A. Right? Let me show you this little bit detail of this. A lot of details are there, right? So let me say, if I show tables, I say drop table books. Table gone. It will be gone from HDFS also. Sorry, ls. It's gone from HDFS also. Let me quit. What will happen here? See, it will create a database log, derby.log, and it will create a folder called metastore.db, which will be similar to a MySQL, right? Similar to MySQL concept, right? It will have logs, it will have binary logs, all those things, right? Where it will keep a track where it is writing, right? All these dat files. So what is happening is, whenever I am running Hive in the default mode, I just untarred Hive, renamed, copied the Hive hyphen default file, told where Metastore is, and just executed Hive command. It is running in this mode, embedded Metastore mode, creating only single JVM. In that, it uses a database called Derby. Derby is also a database, very lightweight database. It creates a Derby database. So you can see here, it creates a Derby log. So I will do rm-rf Metastore. I'm deleting that. I'm deleting Derby also, because in production you will not run this way, because only one user can connect to it. Means once I was at the Hive prompt, no other user can be at Hive prompt. So what we will do, cd hive config, I will go here, I will run this into a non embedded mode, in which I can say the metastore which you keep, the metadata which you keep, instead of keeping in Derby, keep that metadata in MySQL. That MySQL can be on the local box, it can be in the remote box, right? So let me show you this. So now let me close this. Let me go to Hive now. So first of all, what you have to do is, I have to create a file called hive-site. I'm sitting in this directory. There's no file called hive-site, right? There's no file called hive-site. So what I have to do is, first I have to create a file called hive-site. vi hive-site dot xml. Right. I created a file which was not there, wrote text inside it. So let me go to the top of the screen. XML file, opening closing bracket, Metastore local. Why? My MySQL is running locally. It can be remote. I can give multiple stores as well. I will explain you that little bit later, right? So in production, what we will do, we will always run MySQL everywhere. No, there's no Oracle, no Postgres. MySQL is the preferred one. What is the advantage of this? The metadata will now go in MySQL. How will I back up? However you are backing your MySQL, I will create a master slave of my MySQL. So I'm backing the metadata of my Hive. Actual data is going to Hadoop, right? So I'm here saying run local mode. I will say client 1, some table name, connector string. I'm saying user is Hadoop. I'm giving some password, Hive password to connect to it. Save it. Then what I have to do is I have to go to MySQL -u root -p, enter the password. What I have to do here? I have to create that option. Either I can create database in advance, not required. If database not there, it will automatically create it. But what I have to do is I have to create a user which can connect to MySQL. For example, let's create a database. Any database. I'm creating a user identified by a password. I'm giving percentile means any host. I'm granting that permission. So I'm here for the simplicity, I'm giving star star, but here it should be whatever database you give. Metastore db dot that. But I'm saying this is all MySQL, right? How you want to control that. Star dot star. All this is in again in my GitHub. Flush privileges. Correct? No. This is done. No. Now look at it. Now I will not run it by simply saying Hive. I will run Hives in a daemon mode now. I will run Hive in a daemon mode now. So it uses a thrift server, Hive thrift server to run it. Okay, so now it died. PSAUX Hive graph. If I do Hive, it is not running for me. What is the reason why it did not come up? I am telling Hive to connect to MySQL, but it does not have a driver to do that. It does not have a driver to do that. So what I have to do, same thing. Exit from here. I will do cp MySQL driver. I will copy to home, Hadoop, Hive, lib path again. I will again do change ownership in case needed. Anyway, copy does not require because it automatically adjusts the permissions, but just I'm doing that. I will again run this. Okay, I've come to this prompt. Now let me log into MySQL from another prompt. Show databases. Use show tables. So the moment why it was giving error, because it was not able to connect to MySQL because driver was not there. if you remember, I created just this database, but how all these table came? These are created by MySQL. When it came up, all these were populated first time, right? So let me do here, select star from currently empty. But as we write something, I will show you what it has. Show databases. Basis. Nothing is there. So let's do the same steps again. What we have done for initially. Now I'm again doing create a table. Let's say, let me go to this one. Nothing is there. Right? Nothing is there on HDFS. I say create database. See the extension .db. While creating, I've just given a database name. It is creating .db. So I will know by looking at the HDFS structure that this is a database. So let's go one level deep here. Uh, Empty. Right? Currently that database is empty. Now what I will do? Use that database, and I will again do that step. Create table. I will go here and again do this. It creates spokes for me. Currently empty. So now I will again load that data. You can see that here. Now let's go to another side. See, this table is also not populated in MySQL, where it is keeping track of what table is going. Let me select this also, show you this. Which user, which table? It is a managed table. It is a Hive managed table. Right? All these tables will be created. DBS. It is keeping a track. Where is the warehouse location? Which database went where? Who did? So if I exit from here, you will not see anything for Derby now, because now everything is going into MySQL. So the schema, the metadata is going in MySQL, your data is going on Hadoop. You can back up MySQL the way you do MySQL backup. Master, 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 slave, whatever you want. Master, master we will not use, master, slave. Now, what is the one more, right? It's a very, very vast topic. But let me show you one more important thing here. Let's say I'm sitting here. What is happening? As I showed you, the moment I delete a database or a table, it goes from HDFS also, which could be really very dangerous thing, because let's say there might be some data which has been kept by somebody in some location, right, at the file system level, and I'm deleting a table from here. It is removing data for me. Show databases. Let me show you this, what I mean. use. I cannot drop a database till it has tables. I have to remove the tables out of it. Drop pokes, drop table pokes, drop database. This one. So it is gone. So now if I go here, all this is gone, which could be a dangerous situation because somebody might delete my data, because this data might not just be for your database purposes. You might have uploaded some data here, very critical data, petabytes of data, and somebody wanted to upload that into Hive, work something, but the moment it dropped a table, it is gone. So advantage Hive, how it is different from other tables also. Now as you see, I explained to you this directory structure is being created. Instead of coming from Hive way, what I can do, I can take any file, for example kv1.txt. I can simply copy this file in that location. User Hive warehouse, manually I can copy that. I do not need to go by Hive way. I can manually copy in that data structure path. I have to just create the schema, means create database, create table. That's all. Hive will automatically take care of mapping it. That's the beauty of Hive. Hive is designed to quickly upload your data into Hadoop. So how it differs from traditional databases is, in traditional databases, the validation is done the moment you insert data. If your schema does not match, it will give you an error. But in Hive, the validation is done when you query. The moment I upload data, I can copy it manually by using file system command. It will not give me any error. When I query it, if it does not match a schema, it will give me an error. I can simply copy it. So how I can avoid such a situation is, I have to create an external table. Right? Let me just cross this. Let me show you quickly one more example here. Whenever I create a table, I will just proceed that name by saying external table. That's all. Means I log into Hive. I say show databases. That database is not there. Let's say I say create database use. Let me go here, show you. So I was showing you here. It is a Hive managed table. Means Hive is managing it. Now I will create a table. I will put a keyword in front of it saying external. So now Hive knows this table is external to me. I will upload same data again. There are lot of details, right? We cannot cover all this in just one session, right? It itself has a very lot of features are there. How it queries, how it differs from there, right? That has come here. Let me show you this. Books. It has that file. Now let me go here and query for you. It is saying now external table. So what does it mean? It is not controlled by Hive. So if I say here simply drop table pokes, look at here, the table is here. Data is there. It will not go. So you have to be very careful which tables you create external, which tables you create external, internal, where you keep the data. Right? This is how Hive works. Hive has a connectivity to Hbase also. I can connect Hive to Hbase. I can query Hive from Hbase. So we are running out of time. I'm not sure I will be able to demo you Hbase, but let me explain you a few features of Hive. Very important, and how it is different from other databases. Right? This is a common problem which everybody does. So let me just first walk through the architecture. So in Hive, there are two kinds of Hive. One is Hive 1, which I just showed you. There is another two which is called Hive 2, which gives you a B line. By default, I do not have to do anything. B line is a part of it. Anything after Hive 0.14, I am using Hive 0.15. After that, anything after that 0.14, we are using 1.1. So I do not need to worry about that. It gives me two options. When I go by Hive command line, it gives me Hive 1. I can go by B line also. B line is also a Hive tool. How it differs is it gives you authentication. For example, Hive 1 does not give you authentication. Anybody can connect to Hive 1, query the Hadoop, query your data. B line has an authentication built into it. So when I say B line and enter, it will ask me, it has a PAM integration. It will ask you for username and password. I can also build up encryption, right? All those features it has. I can give connection string, which connect database to connect to, all those things, right? Lot of details are there, but we do not have time for that. Okay. So important thing I have to show you is, one is it can run independent, Derby, MySQL mode, which will be used in production. I can run Beeline server, but very important thing here is how the query is done. In my normal NoSql, so in the normal SQL world where I'm running MySQL and Oracle, let's say I have a table A, I have a table B, two tables. I am doing a join on them, right? Let's say this table is 1 terabyte in size. This table is, let's say, 1 GB in size. I'm doing some join. In my MySQL Oracle, it does not matter whether I do A left side, B right side, or B left side, A right side. It does not matter. But in Hive, if I'm doing a join of table A on table B, whichever table I give on my left hand side, it is loaded into the memory. Second one will be streamed from the disk. So if I give a table on the left hand side, which is 1 terabyte in size, it will swap. It will start swapping. It will take hell lot of a time for me to finish the job, because I'm trying to load a table which is 1 terabyte into a memory which you cannot have 1 terabyte memory on a system. So you will either do B and A, or there's a keyword you will put in front of it, right, which you will say streaming. You will write a keyword explicitly in front of a table called streaming. So it will tell it, the Hive, you have to stream this also from the disk, not to load into memory in one go, right? A lot of differences will be there in Hive and traditional databases. So please refer the documentation. I have given the references. Go through them. It will give you an idea. Hbase we are left with. So I will cover Hbase probably in the next class we meet. Hbase has also gained a lot of things. For example, we will set up a single node, then a distributed Hbase. High availability Hbase means one master fails. How failover happens? It automatically does with the help of a zookeeper. Connecting Hive to Hbase, because Hbase does not have, it's a NoSql database. So it does not have select, all those kind of things. You can only do put get. You can upload data by saying put, you can retrieve data by get. So how you will query? How will I do select star from some table? So I have to do a query from Hive. Hive at the backend will query Hbase. A lot of architecture details are there, right? All this ecosystem. It is a columnar database. I will explain you all that. What is columnar database? Hbase example. I will right? For example, in up till now, what we were saying create table, create database. Here we will have no concept of that. Over there we say insert something. Here it is put. Over there we were saying select star from EMP. Here it is scan, right? It is NoSQL space. Right, so I will show you how we will connect this, how we will set up high availability. Zookeeper we have seen in HA, but again Zookeeper comes here, which is inbuilt into Hbase. But I will show you high availability, how you will configure high availability, how you will, I will show you we will fail one of the Hbase masters and see how the failover happens, and I will show you a demo on this. And then how you will connect Hive to Hbase and integration. So today, like we went a little bit in a lot of demos today, so we were not able to complete the Hbase part. So I will give you Hbase in our last class in addition to all these things. Hadoop upgrade, map reduce phases. So up till now I have said map and reduce, but there are a lot of phases: partitioner phase, combiner phase, shuffle phase, how you performance tune them, snapshotting, NFS, Hadoop NFS, and Hbase is left. So all these things we will cover in our last class. So I will just drop an email how you guys let me know whether for tomorrow afternoon or next week sometime, right? So next week it could be any of the weekdays in the evening, or it could be a Saturday, or even a Sunday, right? So I will drop an email as the poll goes. I will conduct the class accordingly, right? So any questions you have, please feel free to drop me an email, reach out to me, right? I will be more than happy to help you out. So one thing I think, I'm not sure I've told you or not, but there's a site called ClickLogic. If you search for this, ClickLogic, if I'm correct, no, just ClickLogic Hadoop. ClickLogic. Yeah, ClickLogic. So it is ClickLogic. Okay, I have to search the site. I will share you an email. So ClickLogic is a site where you can go and take free Hadoop exam. It gives you a simulator. It has 60 questions both for developer and Hadoop admin track. You just create your give your email ID and it creates an account for you. You can go and give 4 attempts on that, right? So it shuffles the database. Every time it gives you 60 questions. So it gives you an idea about if you are preparing for Cloudera exam. Questions Hadoop. It was screen logic. Okay, I forgot it. I will share with you so you can play around with that. Okay, guys. So I will drop you an email with the update when we will be doing our last session. So we are left with the Hbase as well. So in the meanwhile, please go and play around with all the things which I have covered today or till now. And if you have any queries, you have 1 week time to play around. Have any questions, reach out to me, and we will see that in our last class. So I will see you in probably in 1 week's time. Tomorrow we don't have class, most probably, and then we will close this chapter, right? So we will have almost covered all the things. So I will drop you an email. Thanks very much. Have a nice week ahead. Bye bye.